All right, today we're talking about VSEPR. You saw it in your tutorial, valence shell electron pair repulsion. And we use this as a common acronym for this particular theory. It's simply stating that electrons are pushing each other away from each other, and it also has to deal with making Lewis structures. Lewis structures will allow us to determine what the shape is based on the VSEPR theory. How many electrons does every atom need to have? 8. Okay. Now, does anybody remember the exceptions? There's 3 of them.
H, B, E. Hydrogen, boron, and barium.
You're kind of close. If you look up on the
Beryllium, BE.
BE. Okay. You got hydrogen, beryllium, and boron. So they're your exceptions. And as you look at hydrogen, how many does he need in the molecule? Does anybody else have an idea? Go for it. What, 2? Good. Okay. How about beryllium? Are you starting to get into it now? Starting to remember? Come on, someone else. 3? No? Come on. Someone else. Someone else. Come on. What do you think, Yusuf? How many would beryllium need? Hydrogen needs 2. And how many does beryllium need? Do you remember?
3.
No, 4. It goes 2, 4, 6. Hydrogen, beryllium, boron. Okay, so if you look at it on the periodic chart, and I'm sorry in the recording that you can't see this, but I'm pointing to a periodic, I hope I'm pointing, there we go. I'm pointing to the periodic table, and I want you to see the relationship of hydrogen to beryllium. On the periodic chart, from hydrogen to beryllium, you go over 1, down 1. And that's 4, so it's 2 for hydrogen, 4 for beryllium, and 6 for boron, which is across the valley, which is where the transition elements roam. Okay? So these are important. You'll see how they work as we go in and actually do molecules. So here we have hydrogen, and for hydrogen chloride, and we're going to do this now as a molecule. And so I'm going to go up here and let's draw the atoms that are actually in it. Oh my goodness, we don't have touch. Hopefully touch will fire up for us. Come on, get this guy in over here. So we have touch sensitivity. There we go. Oh, cool. There we are. Hydrogen and chlorine. Now, when we did this before, what we were doing was hydrogen, 1 dot. Remember that? Okay. Hydrogen, 1 dot, and chlorine with 1, 2, 3, 4, 5, 6, 7, because that's the number of valence electrons. How do we figure valence electrons? Anyone? How do we figure valence electrons? How many valence electrons does each atom have? Column 1 has 1. Column 2 has. Column 3. 4 is 4. And 5 is 5. 6 is 6. And so on. So, chlorine is in column 7, so he gets 7 dots. Now, it's working. Excellent. It is working. So now we have hydrogen that we write next to chlorine. It's a little bit different. And we have to put it together with a stick. Now, sticks are 2 electrons. So, sharing stick. 2 electrons. And you're going to use sticks in your model kits to put these guys together, to put the atoms together. But now we have to work numbers to be sure that we get a good Lewis structure. So the numbers are like this. We have hydrogen with how many valence electrons? Hydrogen, 1. Okay? And we have 1 hydrogen atom in the molecule. And that gives us, 1 and 1. Okay, and chlorine, how many valence electrons? 7, yes. Times 1 chlorine gives us 7 for a total of 8. That's the number that we have to have in our final Lewis structure. Is this coming back? No? Yeah. Okay. Did you do anything like this in your other class? No? Okay. So it's all new to you. It's not too tough. You're going to get a good understanding of it today. All right. Now we get to do the business of, we got 2 electrons here. We're going to subtract that. We wind up with a total left of 6. And so if I put 6 electrons around the hydrogen, why don't I put them on the hydrogen? He can only take 2. I want to make you believers. Hydrogen, hydrogen. How many does each hydrogen have? 2. Yeah. They don't have them, they're sharing them. Okay? And let's put 1 more hydrogen here. To make hydrogen, one of the hydrogens becomes the central atom. That's this guy. Okay? So, for that guy, how many valence electrons is he now sharing? Yeah. And, if you recall, when we go backwards, I hope this is going to work. Yes? Okay. When we go backwards here, you saw that hydrogen has only 2 electrons. Can have only 2 electrons. He has 1 that he brings in, which is where these numbers come from. Okay? So, no hydrogens in the middle, ever. And now we need to check our Lewis structure to see if we're correct. We need 8 electrons, right? Total. 2, 4, I'm going to do it with the pointer so the people at home can see. 2, 4, 6, and 8. So we have the right total number of electrons. Does hydrogen have 2? Yeah, he's sharing these 2. Okay, the stick represents 2. And does chlorine have 8? Yeah, let's count it. 1, 2, 4, 6, and 8. Notice we got to count that stick twice. Yes. That's how many he had that he started with. But the magic of the sharing is that he gets to look like a noble gas because he's going to share his electron with hydrogen, and hydrogen's going to share his electron with chlorine. And by doing that, they both get to look like noble gases. Who will hydrogen look like now? Helium, right? Yeah. And who's chlorine going to look like? Who's right next door to him? Neon, right? Yeah. Yes. Oh, chlorine, you're right. He's on the 3rd row. Very good. Thank you. I get a shadow or a reflection over there, and I can't see it quite right. So, good. I'm glad you all correct me when it is needed. The touch isn't working. That's okay. We'll just do it here. So, now let's do H2S. Can we put hydrogen in the middle? No. We know we can't do that, so we got hydrogen to sulfur to hydrogen. 2 hydrogens because of that subscript, and 1 sulfur. So hydrogen, how many do we have? Okay, and what's his valence? So the valence is 1. We have 2 of those. for a total of 2 electrons. Fluorine, how many valence? Chlorine, or sulfur, sorry. Sulfur, oops, thinking of the last molecule. Sulfur, how many valence? 6 times 1. Total of 6. Oh my gosh, we wound up with 8 again. That's our total. That's what we need at the end. Remember, we're doing a lot of sharing here. And how many have we got in the structure so far? 4. So we have to subtract that out to find out how many we have left. Now, who needs electrons? Hydrogen or sulfur? Sulfur. Okay. So sulfur is going to get both of those electrons. And by the way, remember, like sulfur right now, pretend that sulfur has a... Oh, I shouldn't do dots. That doesn't work. Let's do some green dots. The green dots are not electrons. The green dots are an imaginary box. And we can only put 2 electrons on each side of our box. So the 8 electrons that sulfur has, and I'll mimic the screen up above. There's our top 2. Those were unshared. There's the bonding shares. There's the bonding pairs, that is. And then there's unshared pair. So wherever you have a Lewis structure, you can only have 2 dots on a side. So that's important to remember as well. Okay? So let's check our Lewis structure out. Do we have 8? 2, 4, 6, 8. That's good. And do we have 2 for the hydrogen? Does this hydrogen have 2? Yeah. Does the sulfur have 8? Yeah. And does this hydrogen have 2? So that's how you know we have a good Lewis structure. And we go on, and let's do nitrogen trifluoride. Now how do we know? Who's in the middle?
I'm in the middle.
You're in the middle?
Sure.
Okay.
I test stuff like every single day.
Oh, nitrogen?
Oh, that metal?
That's not a metal. It's a gas.
Oh.
Yeah,
When you say who's in the metal, I thought like, who's in the metal?
it's okay. So, how do we know whether it's going to be nitrogen or fluorine? Huh? What do you think? What? Electronegativity. Perfect. Here we go. Electronegativity is how much an atom attracts the attraction force of an atom to get electrons. So fluorine is the king of the periodic table. He is the biggest electron grabber known to man. Nitrogen has a lower electronegativity because you see the trend in electronegativity. Oh, I can't pull that. But at any rate, the trend goes from left to right for increasing electronegativity. So nitrogen has a lower electronegativity. So folks, anytime you have fluorine, you don't need to worry about who's going to go in the center. It's always going to be the other guy, because fluorine has the greatest electronegativity of any atom on the periodic chart. When I go to make that molecule then, I put nitrogen in the middle, and I have 3 fluorines that I need 1 stick for each of them. And so let's run the numbers. Nitrogen. How many valence electrons does nitrogen have? 5. Yeah. And how many nitrogens do we have?
1.
Okay, so we have 5 valence electrons from nitrogen. Fluorine. What's the what's the number of valence electrons? 7. Good. And how many do we have? 3. 21. And our total then is 26. And now what we want to do is take out the valence electrons that we already used. So we've used 2, 4, 6. Let's take that 6 away from the 26, leaving us 20. Okay, so now I can give 20 electrons out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Oh, who still needs another electron pair? Nitrogen. 20. How cool, huh? And that shape is this thing that we call the trigonal pyramid. That's this guy. He has an unshared pair right up there that's pushing away the other bonding electrons. Okay? Valence shell electron pair repulsion. Yes? So, trigonal pyramid is the one that you want to describe this guy. But let's check him out. Do we have 26 electrons? 2, 4, 6, 8. Now, each of the fluorines has 8, doesn't it? So when you see that kind of thing, just multiply by how many there are, right? Make your number thing easy. And now we have 3 times 8 is, and what about these guys? And that's the number that we're supposed to have. That's the total. And then we can see that each fluorine has 2, 4, 6, 8, because you got to have all of that right. And we see the nitrogen has 2, 4, 6, 8. Everybody has 8 or their maximum number for the exceptions. And the total has to be 26. Got to have both or your Lewis structure's wrong. Okay? And we'll talk about how do you know when you're going to have more sharing. We'll do that later. But, oh, I didn't erase this screen yet. So let's start this over. And we want to do this from scratch so that we know what we're doing. Touch is not working, so we'll have to do it from here. Okay, and this has got to go down. What did I do? Oh my, let's stop this. Okay, this is silicon trihydride, and let's put them together. Who's got to go in the middle? No hydrogen? No. Okay, no hydrogen can't go in the middle. So, Si, and now we've got to align our screen, so I'll turn off the... Okay, so we put silicon in the middle, and we'll put the hydrogens outside. Now, you try to get ahead of me. See if you can build this on your own. Make sure you get the numbers right. Working ahead of me? Try to stay ahead of me. Now, I've already used 2, 4, 6, 8. used all my electrons. So if I've used all my electrons, now what? I'm done, right? Okay, so let's check it out. 2, 4, 6, 8. That's my number, right? Does each hydrogen have 2? They do. Does silicon have 8? 2, 4, 6, 8. I've got me a good Lewis structure. What do you think, folks? Is this making sense? Good. Okay, that's it for now. I'm going to put you on your own for the rest of them for that lab sheet, and I hope you found this helpful.